Today, we are going to work on the second category of calculation in this chapter, which is the calculation based on chemical formula. But before that, let's have a quick look at what we can do right now, what we have learned last time. This is what we learned for the first kind of calculation in this chapter. Given the mass of something or moles of something or number of particles of something, we can go back and forth to get the other two. Okay, given grams, we can get how many moles are there in that grams or how many particles are there in that many grams. So given information of a substance, we can get the other two kinds of information about the substance. All right, we are about to start today's work, the calculation based on chemical formulas. Since the calculation will be based on a chemical formula, so let's take a closer look at a chemical formula before that. Actually, there are two different ways to look at a chemical formula. The first one is called microscopic view. The second one is called macroscopic view. What are they? What are the different? Let's look at the first one, the microscopic view. In the microscopic view, the numerical subscripts in the chemical formula tells you the number of atoms of all kinds of elements in one formula unit of the substance. So in this case, you can say in one molecule of diphosphorus pentoxide, P2O5, there are 2 atoms of phosphorus and 5 atoms of oxygen. Oh, we know this. We learned this a long time ago. This is how we look at a chemical formula when we first introduced the chemical formula. So the so-called microscopic view of our chemical formula is no different from what we learned before. We are looking at formula as a molecule or a formula unit. The subscripts tells us how many atoms are there in that unit. Well, now, since we have introduced the mole concept, we have a different way to look at our chemical formula now, which is called the macroscopic view. In the microscopic view, the numerical subscripts indicates the number of moles of atoms of each element in 1 mole of a substance. Again, using P2O5 as an example, the formula P2O5 tells us in every 1 mole of P2O5, there are 2 moles of phosphorus and 5 moles of oxygen. All right, so now each formula can represent 1 mole of that substance instead of 1 molecule or 1 formula unit. All right, so each formula represents 1 mole, then the subscripts tells us the number of moles of each of the elements present in 1 mole of that substance. Okay, so basically you can say in 1 mole, let's use a phosphorus in the formula example. So in one mole of P2O5, there are 2 moles phosphorus. As you can see, this one tells us a relationship, the molar relationship between phosphorus and the formula. Do you see that? If we know some information about formula, using this molar relationship, we can get information about phosphorus. All right, maybe you can think about that, or maybe you're not that clear about it. Let's move on then. All right, calculation based on chemical formulas. Okay, in the first kind of calculation, we introduced a flow chart that we kept following. In that calculation, that flow chart basically is half of today's flowchart. Given grams of something, we are using A as example. Given grams of A, we can get moles of A, particles of A back and forth. Well, today, we are going to expand the flowchart to add another half of the flowchart. In the middle, the bridge that connects the two charts is the chemical formula subscripts. The subscripts tells us the molar relationship between two different things. As you can see, we can go from moles of A to moles of B back and forth. If you're still not quite clear about what's going on, let's take a look at a practice, and we're going to using this flowchart to set it up. How many moles of hydrogen atoms are present in the 2.5 moles of ethane? All right, let's identify what is given, what is wanted. Given information is 2.5 moles of ethane. So we know moles of ethane. We know moles of ethane in this question. What is wanted? The wanted is moles of hydrogen. This is different from what we learned or what we practiced before. Before that, when we get moles of something, we will be asked about grams of the same thing or particles of the same thing. But now we are given moles of ethane, we are asked about moles of hydrogen. These two, hydrogen and ethane, are different. How do we do this? Well, let's map the question to the flowchart again. Let's do that again. We know moles of something, so you can consider we are in this location. We know moles of A. In this case, A represents C2H6 ethane. We know information about moles of ethane. The wanted information is moles of something else, moles of hydrogen. So it's not moles of A, it's moles of B. In this case, we are going to moles of B. In this case, B is hydrogen. All right, so we need to go across this flowchart from one side to the other side. Well, let's move back to our setup. Given unit, moles of ethane, wanted unit, moles of hydrogen. The two units are different. If they're different, you need a conversion factor. You need to make sure the unit with given information is at the bottom of the conversion factor. The unit of wanted information is on the top of the conversion factor. All right, so what is this? Where do we get this information? The relationship between moles of hydrogen and moles of ethane. Well, the flowchart, let's move back to the flowchart. Flowchart tells you get this relationship from the formula subscripts. We just learned on the last slide how to look at a chemical formula. Now, C2H6, it tells us that in every 1 mole of C2H6, there are 6 moles of hydrogen. We just learned this. This is what we learned from the macroscopic view of a formula. It tells us the molar relationship between everything in this formula. Make sense? Let's put this in 2.5 mole. 2.5 times 6 divided by 1, that's 15. We have 15 moles of hydrogen in 2.5 moles of ethane. Another practice. How many grams of carbon in 1.5 moles of CO2? All right, let's map our question to the flow chart. First, given information, moles of CO2. We know moles of something. Okay, we're here. We know moles of A. Well, you can choose to say we know moles of B. That's fine. You just have to go backwards later on. Either way, it works. Okay, I chose A. We know moles of A. We are in this box right now, and A is CO2. We know moles of CO2. Wanted information? Grams of carbon. Grams of something. Is it grams of A or grams of B? Of course, grams of B, because it is carbon. It is different from CO2. Therefore, this is our destination. We need to know grams of carbon eventually. All right, so once you know this, you know you need two conversions. The first, convert from moles of A to moles of B, which is moles of CO2 to moles of carbon. The second goes from moles of carbon to grams of carbon. So starting point, the given information moles of CO2, eventually you're going to get grams of carbon. And you know you need two conversion factors. The first one goes from moles of A to moles of B. From always at the bottom, moles of A is CO2. Wanted, the destination right now at this step is moles of B. Moles of B, B is carbon in this case. By the end of here, we don't know what number we are going to get yet, but we know by the end of here, we know information about moles of carbon will be in this box. Now we need to go from this box to the final destination, grams of C. So from at the bottom of the conversion factor. No, from, yeah, moles of carbon. Final destination, grams of carbon on the top. Now let's put all the numbers in. 1.5 mole. What is this conversion factor? This conversion factor is the formula subscripts. The flowchart tells you what it is. CO2 tells you in every 1 mole of CO2, you have 1 mole of carbon. What is this conversion factor? Well, it is the molar mass. We learned that last time. The molar mass of carbon, 12.0. Okay, 12.0 grams of carbon in 1 mole of carbon. So you go from 1.5 times by 1 times by 12.00 divided by 1 divided by 1, you get 18 grams of carbon. Another example. How many grams of carbon are there in the CO2 sample that contains 32 grams of oxygen? What is this talking about? Well, it says that there is a carbon dioxide sample. In it, there are 32 grams of oxygen. If that's the case, how many grams of carbon will be in that sample? All right, let's identify the given information, wanted information. Given information, grams of oxygen. Wanted information, grams of carbon. Once you identify this, map them onto the flowchart. We know grams of something. Again, I use grams of A as the box that we know information about. In this case, A is oxygen. Wanted information is grams of something else. And clearly, this is wanted information. You need to go there eventually. B, in this case, is carbon. Once you map them out, you know you will need 3 conversion factors. Let's set them up now. The first conversion factor, you need 3 of these. The first conversion will convert from grams of A to moles of A. So from at the bottom to on the top. A is oxygen. By the end of here, you know you will be in this box, moles of A. Second, you're going to go from moles of A to moles of B. All right, from at the bottom, moles of A is oxygen, 2 moles of B, 2 on the top. B is carbon. By the end of here, you are in this box, moles of B. The third conversion, you're going to go from moles of B to grams of B. Remember, B is carbon in this case. From at the bottom, moles of carbon, 2 on the top, 2 grams of carbon. Everything's set up correctly. Now let's start putting the numbers. 32.0 is the starting point. What is the first conversion factor? The first conversion factor is the molar mass of A, which is oxygen. Oxygen, it is provided 16.0 in 1 mole. The second conversion factor, well, the flow chart tells you to do the second conversion, you need a formula subscript, CO2. CO2 tells you for every 1 mole carbon, there must be 2 moles of oxygen. Okay, that's what you know from the formula subscripts. The third one, molar mass of carbon. Carbon is 12.0, provided 12.0 grams 1 mole. In the case, if they do not give you these atomic mass units of the element, you need to use periodic table in the future. All right, let's do the calculation. You punch in 32.0, you multiply it by 1, multiply it by 1, multiply it by 12.0, then you divide it by 16.0, divided by 2, divided by 1. You keep multiplying all the numbers on the top, keep dividing all the numbers at the bottom. After that, you're going to get 12.0 grams of carbon, 3 significant figures. All right, we have completed 3 examples together. Now, here are 2 questions for yourself to practice. Remember, when you do this, you identify the given information, identify the wanted information, then map them onto the flow chart. Once you're done with that, you know how many steps of conversions you will need. Then, 1 box at a time to complete the conversion factor, from box at the bottom to box on the top. Once they're done, put the numbers in, look at the flow chart, it tells you what the numbers should be, and then finish the calculation. You can pause the video, complete the 2 questions, come back for the answer keys. Here is the answer key for both of them.